Here we go, scholars, with the last 4 derivative formulas that you're going to need for calculus AB. If you take the derivative of the function e to the x with respect to x, the derivative is e to the x. So there you go. E to the x is the only function who is its own derivative. If we're going to write that using the chain rule, since we know the chain rule now, the derivative with respect to x of e to the u is e to the u times du dx. If you put that in your notes, we'll do an example. So I want to find dy dx if y is e to the x plus x squared. In this case, you can see that u is x plus x squared, and I do have a function y equals e to the u. So according to the formula you just wrote down, dy dx is e to the u times du dx. I'm going to use u equal to x plus x squared. Du dx is 1 plus 2x. And there I have dy dx is e to the x plus x squared times 1 plus 2x. Now what if I want to take the derivative of an exponential function and the base is something besides e? So we call this the arbitrary exponential function. So the derivative of some other number a to the x is a to the x times the natural log of a. Notice this works for e to the x too. The derivative of e to the x would be e to the x times the natural log of e. What's the natural log of e? That's just 1. So again, incorporating the chain rule, the derivative with respect to x of a to the u is a to the u times the natural log of a times du dx. Put that in your notes and we'll do an example. Alright, now here I have a function, y is pi raised to the 3x squared. So I have a base that is not e, and I have an exponent that's a function of x. So in this case, a is pi, u is 3x squared, and I want to take the derivative with respect to x. So dy dx is that exact same function I started with, pi to the 3x squared, times the derivative of the exponent, du, which is 6x, times the natural log of the base. In this case, the base was pi, so I multiply by the natural log of pi.